Hey everyone, so in this video what I want to cover is linear equations in one variable and proportions. Okay, this video might be a little bit longer. There's quite a bit to cover, so let's get to it. I will tell you while I'm switching screens that I am using my tablet today, so the penmanship will be better. So hopefully you like it. We'll see. All right, so we're talking again about linear equations. Let me get black ink. There we go. Okay, so we're going to talk about linear equations in one variable. And then we're going to talk a little bit about proportions. Okay, the assumption in this video is that you have seen solving linear equations at some point in your past. So this is going to be somewhat of a review, but I'm going to try to throw in some extra examples at the end just for extra practice. Okay, so if this is a little fuzzy, just keep working on it and make sure to watch all the examples at the end for, like I said, extra practice. Now on your worksheet, the first definition that says linear equation, I'm going to completely change it. So you can just mark that definition out and fill it in with this one. So a linear equation in one variable is any equation of the form ax plus b equals 0, where a and b are real numbers such that a does not equal 0. So when we're talking about real numbers, we just mean that that could be whole numbers, it could be integers, so positives, negatives, it could be decimals, it could be fractions. So any typical number that we would see, that's what a and b could be. What's most important here is you're going to have one type of variable. So you could have multiple x's throughout your equation, but you would combine them into a single term where you just have one x. So you wouldn't have like x's and y's, for example. So you're just going to have the one variable. Okay, this type of equation has one solution. All right. So again, that very first definition on your worksheet, you can mark it out. There was a typo in it and fill it in with this. Okay. From here on out, we're going to follow the worksheet until the very end, and then I'm just going to add some extra problems to it. Okay. So solving, this is a process. Okay. And this is the process where you find all values of the variable that make the equation true. So when we have a linear equation in one variable, our goal is to solve that equation. And again, solving is the process where we find the value of the variable that make the equation true. Okay. The whole idea is we're going to take steps to isolate the variable to determine its value. Okay. And while we're doing this, we do need to maintain balance. That equation, when it is given to you, even though the left and right may look different, they represent the same amount. Okay, so as we're doing stuff to isolate the variable, we need to make sure we keep the balance. That means if I add or subtract on the left-hand side of the equation, I need to add or subtract by the same value on the right-hand side of the equation. So whatever you do to one side of the equation, you have to do it to the other side as well. Okay, so then we have that these values for the variable, they are called solutions. So once you figure out the value for the variable that makes the equation true, we know that we can call them solutions or roots. And sometimes instead of roots, you will see zeros, okay? But generally, I think this book that we use, it goes with solutions and roots for now, okay? And then when we find this solution to the equation, we write it a certain way. So we have something called a solution set. And it is the set of all solutions to the equation. All right. Now, in this particular section, we're talking about linear equations in one variable, so they have one solution. There are other types of equations out there where you would get more than one solution. But for this section, we're generally just dealing with one single value that satisfies the equation. Okay. So there you have some intro definitions. Okay, again, remember, we're treating this as if it's somewhat of a review, like you've seen some of this before. So if you're struggling a little bit, slow the video down, rewind the video, rewatch parts, make sure you look at all the examples. And as I work through examples, make sure you're writing them down and working them out too. Okay, now there are steps to solve. Okay. The steps to solve an equation, the first step is we simplify. And when we simplify, what we're really doing is eliminating parentheses and combining like terms like we did in the previous section. Okay. The second step is to collect variables on one side. So you want to get all of your variables in a single term, and you want to get it to one side of the equation. Generally, we'll do this on the left-hand side, but you could do it left or right. And then you want to get constants on the other side. So constants are the numbers that are just by themselves. So technically, there is a property called the addition property of equality, and it allows you to add and subtract terms from either side of the equation. That's what you're doing in step 2. You're applying the addition property of equality. You're moving things from one side of the equation to the other using addition or subtraction. And again, the goal here is get all of the terms that contain variables into a single term on one side, get all of the constants into a single term on the other side. Step 3 is we isolate the variable and solve. So what's really happening, whoops, I forgot a letter. We isolate the variable and we solve. So what we're really doing is we're dividing by the coefficient of the variable. And that's what we're doing when we isolate the variable and solve. This is technically the multiplication property of equality. The multiplication property of equality says once you get it down, your equation down to the point where you have a single constant term equaling a single variable term, you just undo the multiplication of the variable and its coefficient. And then the fourth step, you don't always have to do it, but it's always a good idea to know how to do it so that you can check your answer. So I don't always require it, but I am going to show it on several of the examples in this video so that you understand how to do it. And that's a good tool to have because when you're, for example, taking a test, you might want to check your answer. You might want to have just that extra little tool in your back pocket that lets you double check and see if you've got another, like if you've got a mistake, you can find that out by checking your solution. So it's just another way to check your work before you turn in a test. Okay, so let's look at some examples. Our first example is 5x minus 8 equals 72. This is a pretty easy example. It's only going to take us a couple of steps and we'll have the solution. But basically, our goal, if we go back to the previous screen, we want to simplify by eliminating parentheses and combining like terms. Well, we don't have any, okay? We don't have any parentheses to get rid of. If you look at the left-hand side of this equation, everything's combined. The right-hand side, everything's combined. So we then want to move to step 2. So step 2 says collect the variables on one side, the constants on the other. So if we go back to this problem here, we have all of our variables in a single term, but that term is not by itself. So what we want to do is we want to isolate the 5x. And to do that, we need to undo that subtraction of 8. So how do you undo subtraction? Well, you use addition. But remember, we have to maintain equality. So if we do something to the left, for example, adding 8, then I have to do the same something to the right. So add 8 to both sides. On the left, negative 8 plus 8 just becomes 0. 5x minus 0 is just 5x. And then on the right, 72 plus 8 is 80. All right, so if we go back to our list of steps, we didn't have to do step 1. We just finished step 2. So step 3 says isolate the variable and solve. We do this by dividing by the coefficient of the variable. So let's see what that looks like. So right here, I've got my variable term on one side. I've got a constant on the other. Life is good. What I need to do now is figure out the value of just x. To do that, I undo the multiplication of 5 and x. So I divide both sides by 5. On the left, 5 divided by 5 is 1. 1 times x is just x. And then on the right, 80 divided by 5 is 16. So as it stands right now, we're pretty sure our solution is 16, but let's check our answer. So the way we would check our answer is this. We would go back to the original equation, but anywhere I see an x, instead of putting x, I'm going to put a 16. All right. So then I'm going to use the order of operations to simplify the left-hand side. So I start with multiplication. 5 times 16 is 80. So I get 80 minus 8 is 72. Well, 80 minus 8 is 72. And so then we just have to ask ourselves, does 72 equal 72? Absolutely. So we can say with confidence that our final answer is that x is equal to 16. So here's how you write your answer. You take a set of curly braces and you put the value for the variable inside. So the solution set here is 16, okay? I had to get a sip of water. Let's try another example. So let's say this time we do 5x minus 4 times, in parentheses, x plus 9 equals 2x plus 3. So you can see right off the bat, this is a somewhat more complicated equation. It's not going to be necessarily terribly difficult, but we'll have more steps in this process here. Okay, so the first thing I want to do if I go back to my steps is I want to simplify. And we do that by eliminating parentheses and combining like terms. So let's do that. First thing I'm going to do is get rid of parentheses, and we do that by using the distributive property. So I'm going to take this -4 and I'm going to distribute it through the x plus 9. So first thing, I'm just going to drop down my 5x, and then I'm going to take -4 times x, which gives me -4x. Then -4 times +9 gives me -36. Watch your signs. And then I'm just going to rewrite the right-hand side of the equation. One thing I will encourage you to do is as you're solving, do one step at a time. And as you do that step, just rewrite the equation. Keep rewriting the equation until you get to the final step. One of the worst things you could do is try to do individual steps and then piece things together at the end. You lose signs, you lose terms. So just continue to rewrite your equation for each step that you complete. So we have so far eliminated parentheses. Now we need to combine like terms. So if I go over here to the right-hand side, 2x plus 3 is as easy as it's going to get. I don't have any like terms. The 2x is its own term. The 3 is its own term. So you want to get each side to the point where you have at most one variable term and at most one constant term for now. The left-hand side needs a little work. If I look here at the 5x minus 4x, I can simplify. So 5x minus 4x is just 1x. And then there's nothing to combine with the -36, so I bring it down. So at this point, we have completed step 1. We've simplified. So again, simplified means the left and right have at most one variable term each and one constant term each. Now we're going to look at step 2. Step 2 is where we collect all of the variables on one side of the equation and the constants on the other. So in this example, I do have variable terms on both sides of the equation. Now, I am going to show you how to move this 2x to the left, mostly because I want you to know how to deal with a negative. Just know that you absolutely could move the 1x to the right, but I do have a reason for showing you the 2x to the left. So I'm going to move my variables to the left. That means I need to move this positive 2x. The way we would undo plus 2x is by subtraction. And remember, if I do something to the right or the left, I have to do the same thing on the other side. So I need to subtract 2x from both sides of the equation. On the left-hand side, x minus 2x is -1x, or just -x. I bring down my -36 and my equals. And then on the right, 2x minus 2x is 0. 0 plus 3 is 3. All right. So I've got all of my variables on one side of the equation. I need to get the constants on the other side. So that means I need to move minus 36 to the right-hand side. I do that with addition. So I'm going to add 36 to both sides. On the left, negative 36 plus 36 is 0. Negative x plus 0 is negative x. On the right, 3 plus 36 is 39. So it seems like I'm done, but I showed you this way on purpose. You're not actually done. You're done when you have a single positive variable equaling a constant. Well, we have a single variable, but it is not positive. So this is really like negative 1x. So I'm not quite done solving. I need to divide both sides by negative 1. On the left-hand side, negative 1 divided by negative 1 is positive 1, which gives me positive 1x. And then negative 1 times 39 is negative 39. Okay, so now I want to check my work. So I'm going to go back to the original equation. Anywhere I see an x, I'm going to plug in a negative 39. And I'm going to simplify using the order of operations on the left and right. And hopefully we will get that this is a true statement. Okay, so simplifying first, I'm going to do what's inside the parentheses right here. And I can do the multiplication here and here. Okay, so 5 times negative 39 is negative 195. I get minus 4 times, well, negative 39 plus 9 is negative 30. 2 times negative 39 is negative 78. And then I drop down my plus 3. So I did 3 big things all at once. So slow this video down, rewatch it if you need to. All right. Now what I need to do is the multiplication of negative 4 and negative 30. So I'm going to drop down my negative 195. Negative 4 times negative 30 is plus 120. And then on the right, negative 78 plus 3 is negative 75. On the left-hand side, I've got one more step. Negative 195 plus positive 120 is negative 75. So does negative 75 equal negative 75? Absolutely. That verifies that our solution really is negative 39. And we're going to write it out in solution set notation. Okay? So there you have it. Hopefully that's a nice review of how to solve equations. Again, at the end of this video, I'll do some extra problems that are not on your worksheet just for extra practice. But that's the general idea for now. So for the next step, what we want to look at is clearing fractions. I can't tell you how many students I have that tell me how much they hate fractions, and then when they have the chance to eliminate fractions, they don't. Okay, so this is going to be mandatory. All right, if there are fractions, so if you have a linear equation in one variable and there are fractions, we must, and I'm going to underline must, we must first multiply each side by the LCD. Okay, so LCD is what we're looking for there. And in case you can't remember, LCD stands for least common denominator. Okay, and the least common denominator, when you're dealing with fractions, you look at the denominators and you want to find the smallest denominator that all of the denominators you're dealing with would divide into evenly. Okay, so again, LCD fractions should definitely be reviewed. If you're struggling with that, let me know and I can get you some more support. But for now, let's look at a couple of examples. So the first example I have is x over 2 equals 20 minus x over 3. So what we want to do first is we want to look at 3 and we want to look at 2. And we need to figure out what is the LCD. Okay, so the smallest number that 2 and 3 would divide into evenly would be 6. So what I'm going to do is multiply both sides of the equation by 6, but I take it one step further. I just go ahead and multiply all of my terms by 6. So what we would ordinarily do is multiply the left and right by 6, and then we may or may not have to distribute. I just go ahead and multiply every single term by 6. That way, I don't have to worry about distributing in another step. So I'm going to take 6 times x over 2 equals 6 times 20 minus 6 times x over 3. Okay, so again, I just jumped straight to multiplying every single term by the LCD. Doesn't really save a step necessarily. That's just how I approach it. So now what we want to do is we want to look at our denominators. This 2 right here, we'll divide into 6 3 times. So I get really just 3 times x. So 6 times x over 2 is just 3x. Next, I get 6 times 20, which is just 120. And then for the last term, this 3 in the denominator divides into 6 twice, which just leaves me with negative 2x. Okay, now I can't speak for the masses, but I would much rather deal with this equation than what we started with. Okay, so the whole idea of multiplying all of the terms by the LCD, it just gets rid of all the fractions, and then you have a nice, much easier equation to solve. So let's go ahead and solve it. So we don't have any parentheses. We don't need to combine like terms. The left and right hand sides are both as simple as they can get at this point. What we do want to do, is collect all of the variables on one side, the constants on the other. So this minus 2x here on the right, I want to move it to the left. So to undo that subtraction, I would add 2x. To maintain balance, we add 2x to both sides. So on the left, 3x plus 2x is 5x. On the right, I get 120, and then negative 2x plus 2x, that just becomes 0. So 120 plus 0 is just 120. So now I'm at that step where I need to isolate the variable and solve. So to do that, I need to undo the multiplication of 5 and x. We undo multiplication with division. So I'm going to divide the left and right hand sides by 5. On the left, 5 divided by 5 is equal to 1. 1 times x is x. And then on the right hand side, 120 divided by 5 is 24. Okay, so let's check our work. So we think that the solution is 24. So we're going to rewrite the original equation, but anywhere we see an x, we're going to put a 24. So let's see, 24 divided by 2 is 12. 20 is just 20. 24 divided by 3 is 8. So I get 12 equals. And then let's see, 20 minus 8 is 12. 12 certainly equals 12. So we can say with confidence our solution is 24. All right. So hopefully that's not bad. Again, if you see a linear equation in one variable that has fractions, just get rid of the fractions right off the bat. All you got to do is multiply by the LCD. So let's look at one more example. Let's say this time that we have 2x over 3 equals 7 minus x over 2. We want to know what is the LCD. So looking at our denominators, we've got a 3 and 2 again. That tells me the LCD is 6 again. So I'm going to multiply all 3 terms by 6. So I get 6 times 2x over 3 equals 6 times 7 minus 6 times x over 2. And just like we did in the previous example, we're going to simplify each term. So the first term, the 3 in the denominator divides into the 6 twice, and I get 2 times 2x, which is 4x. 6 times 7 is just flat out 42. And then for the last term, the 2 in the denominator divides into the 6 3 times, leaving me with a minus 3x. Sorry, I had to stop for water. So now we have an equation to solve. We don't need to simplify. There's no parentheses. There's no combining like terms that we can do at this point, but we could collect all of the variables on one side, constants on the other. So let's do that. I want to move the minus 3x from the right to the left. To undo that subtraction of 3x, I would add, and I just need to make sure I do it to both sides of the equation. So 4x plus 3x is 7x. 42 is just plain old 42. And then negative 3x plus 3x is 0. 42 plus 0 is just 42. So we've got a single variable term on the left, a single constant term on the right. Now we need to do the whole isolate the variable and solve. So I need to undo the multiplication of 7 and x. To do that, I divide both sides by the coefficient of x. So to undo that multiplication, I would divide. On the left, 7 divided by 7 is 1. 1 times x is x. On the right, 42 divided by 7 is 6. Okay, let's check our work just to make sure. That's a C, I promise. Well, it looked better before you know what? I'm just going to start over. We're going to check our work. So we're going to rewrite the original equation, but anywhere I see an x, I'm going to put a 2. No, I'm going to put a 6. I'm sorry. So anywhere I see an x, I'm going to put 6. So then I get 7 minus 6 over 2. Okay, so I've rewritten the equation. Anywhere there was an x, I replaced it with a 6. Now let's just simplify. So on the left, 2 times 6 is 12. So I have 12 over 3 for now. On the right, the 7 stays for now. And then 6 divided by 2 is 3. On the left again, 12 divided by 3 is 4. On the right, 7 minus 3 is 4. 4 certainly equals 4. So again, we can say with confidence that our solution is definitely 6. Okay, so that's a pretty quick review on solving linear equations in one variable and then solving equations that contain fractions. Next up, we want to talk about proportions. Okay, proportions are types of equations. We'll get to that in just a second. But first, let's look at a couple of definitions. So when you're comparing two quantities by division, you're talking about a ratio. So if you have a comparison of quantities by division, that's just a ratio, okay? As far as examples go, any fraction is considered a ratio. So we could have something as simple as 2/7. Okay, we're comparing 2 to 7. Or we could have something like 3 cats to 5 dogs. When you have different units, when you're comparing two different things like cats and dogs, you would generally call that a rate. So a ratio is just any comparison of two things, but specifically when you're dealing with different units, you'd call it a rate, okay? So next up, we have a statement that two ratios are equal. That is a proportion, okay? So a little bit further, just so you don't feel like this is completely disjoint, a proportion is a special type of equation. So it is a special equation, okay, where two ratios are equal, okay? So it is an equation, all right? And then next up, to solve a proportion, we cross multiply. Multiply and solve, all right? So proportions are special types of equations. It's a statement where two ratios are equal. And the way we solve that is we cross multiply. So let me show you what I mean by cross multiply. Let's say we have two generic ratios. We have A over B equals C over D. Well, when you have a situation like this would be considered a proportion. You take the first numerator and the second denominator. You take the first denominator and the second numerator and you multiply them. So to cross multiply, you literally multiply the diagonals. Okay, so we would get A times D, and it has to equal B times C. So if that original statement is true, if A over B truly does equal C over D, then A over D truly equals B over C, or not A over D. Let me say that again. If A over B truly equals C over D, then A times D has to truly equal B times C. So what we want to do is we want to go from here to here, and then we can solve. So let's look at a quick example of that. Let's say that we have 22 over 60 minus x equals 2 over x. Well, the issue here compared to what we did over on this slide and this slide is with these two examples where we were clearing fractions, the denominators in the fractions were just numbers. There was no real issue. We can find an LCD when we're dealing with just numbers. But when you get to something like this, where the denominators are no longer just numbers, then that whole idea of an LCD becomes much more complicated. That's a much higher level algebra problem. That's something you would see in like a Math 171 class. So for us, if you see a problem like this, where the denominators are not numbers, and it's a proportion where you have a single expression equal to a single expression, what you would do is instead of finding an LCD, you would cross multiply. So we're going to multiply like such. Okay. So I'm going to get 22 times x, that's just 22x. And then I'm going to get 2 times, in parentheses, 60 minus x. I'm multiplying that 2 by that entire first denominator. So I'm going to start by just writing it in parentheses. And then I'm going to start the solving process. So I get 22x equals, I definitely want to distribute to eliminate parentheses. So 2 times, excuse me, 2 times 60 is 120. And 2 times negative x is negative 2x. All right. So now I have something that I can easily solve. I can't combine like terms yet at this point, but I can get all of my variables to the left and my constants to the right. So I'm going to start by adding 2x to both sides. This minus 2x on the right, I want to move it to the left. I do that with addition. So that gives me 24x equals 120. Negative 2x plus 2x is 0. 120 plus 0 is just 120. I'm going to move this over a little bit so I still have room on my screen. So I have 24x equals 120. Now I need to isolate the variable and solve. To do that, I undo the multiplication of 24 and x. I undo multiplication with division. So I divide both sides by 24. On the left, 24 divided by 24 is 1. 1 times x is x. And then 120 divided by 24 is 5. So we would say here the solution to this proportion is 5. And since I'm out of room on this screen, I won't show you how to check your answer, but you would check it just like we did previously. You would rewrite the original equation. Anywhere you see an x, you put in a 5, simplify, and see if you get a true statement. Okay, let's look at a couple of word problems with proportions. So the first word problem that we have, we're dealing with property tax on a house. So property tax on a value of $250,000 is $3,500. So in this particular region, if you have a house that is valued at $250,000, you're going to owe $3,500 in taxes. So the question that we want is, what is the tax on a property valued at $420,000? So here's what you do. We know that a proportion is a statement or an equation where two ratios are equal. We have two sets of information here. We know that if you have a property valued at $250,000, you're going to owe $3,500 in taxes. In that same region, there's going to be a proportional relationship with property taxes and home values. So we're going to set up the first ratio with the information that we know. We know that if we have a $250,000 property, we are going to be expected to pay $3,500 in tax. And if we set that equal to another ratio based on the property that's $420,000, we can set it up where the unknown is the tax for this second property. We're going to call the tax on the $420,000 property just plain old X. We've now set up a proportion. One value's missing. We can solve for this. So we would start by cross multiplying, just like we did in the previous example. So I'm going to get 250,000 times X. And then I'm going to get 3,500 times 420,000. If we keep these numbers exactly as they are, we're definitely going to get some wild zeros here. So just be really careful, be organized, use the commas for every 3 digits. But for now, we've got our 250,000 X. If you multiply 3,500 times 420,000, you're going to get this gigantic number. So you get 1,470,000,000. And even though these numbers look gigantic, it's the exact same process. We're going to undo the multiplication of 25 or 250,000 times x by dividing. So we're going to divide both sides by 250,000. On the left, the 250,000, they just cancel out. We say that 250,000 divided by 250,000 is 1. 1 times x is x. And then if we take the 1,470,000,000 and divide it by 250,000, you should get 5,880. So here's the thing. When you're dealing with a word problem, make sure you describe your answer in words. 5,880 doesn't mean a thing to the reader, but if you say $5,580 in tax is owed on a $420,000 property, suddenly that answer makes a lot of sense. So make sure when you're dealing with a word problem, you label or describe your answer some way. All right, so that's our first proportion problem. Let's look at one more. So for the next problem, it's a little bit lengthier, but you have a wildlife biologist catch, tag, and release 120 deer back into a wildlife refuge. So we have a wildlife refuge with, it turns out, an unknown number of deer. What we know is that 120 were caught, tagged, and released. Okay, later, 150 deer were observed, of which 25 were tagged. Okay, so there's some kind of wildlife refuge. At some point, biologists captured, tagged, and released 120 deer. Later, 150 deer were observed, of which 25 were tagged. Assuming there's some kind of proportional relationship here, how many deer could we expect in this refuge? So let's start with what we know. We know this right here. I'm going to underline it in red. We know this right here. This is a proportional or this is a set of information that we know, and there's going to be a proportional relationship to the 150 deer that were observed and the number of tagged compared to the total number tagged. So let's see what we can come up with. We could say that there are 150 deer, and of those 150 deer, 25 are tagged. Now, we have no idea how many deer are in the total refuge, but we do know how many deer total were tagged. 120 deer total were tagged. So what that leaves us is the unknown of how many deer are in the actual refuge. But with this setup, with this proportion, we can get an estimate for how many deer are actually in this refuge. So we've got a proportion. We're going to cross multiply. So I get 25 times x. And then I get 150 times 120. So simplifying, I get 25x equals 18,000. I need to undo the multiplication of 25 and x, so I divide both sides by 25. 25 divided by itself is 1. 1 times x is x. And then 18,000 divided by 25 is 720. So we would say something like there are approximately 720 deer in the wild, I forgot the word deer. Deer in the wildlife refuge. So as far as word problems go, proportions are not the worst ever. And so you have a proportion when you're dealing with similar situations. One situation you have full information, the other situation you only have half of the information. You can then set up a proportion and solve. All right. So the next page in your notes, we're going to talk about classifying equations. Okay. So we'll start with some definitions, and we'll look at some examples. And then remember, at the end of this video, I'm going to throw in a few extra examples. If you feel good by the end of the regular content, that's fine. If you feel like you need to see more examples, definitely watch the end of the video with the extras, okay? So classifying equations. Anytime you classify something, it's just a way to group things by some common feature. So here we're grouping equations based on solution type. All right. Now, at the beginning of this video, if I go way back to the first slide, we said a linear equation in one variable is any equation of the form ax plus b equals 0, where a and b are real numbers, such that a is not 0. I then followed it up with this type of equation has one solution. Well, yes, that is true. But there are two special cases where you could have an equation that has no solution, or you have an equation that has infinitely many solutions, okay? So let's talk about the three classifications. The first classification is a conditional equation. With a conditional equation, one value for the variable satisfies the equation. Okay? That means there is one solution. Okay? And just a little hint, everything we've solved so far has been a conditional equation. Okay, so the typical equation for this section, it's going to be a conditional equation. The two special types are called an identity and a contradiction. So let's look at identities first. So when you have an identity equation, all real numbers satisfy the equation. And these equations have infinitely many solutions. Okay, and what we would say for these equations, we would write it really funny. We would write it the little squiggly curly brackets or curly braces, whatever you want to call them, and then you write an x with a vertical line. That quite literally translates to solutions for x such that, and then you say x is all real numbers. All right. So that's kind of the weird way we would write our solution there. The second type of special equation is a contradiction. And the issue here is there's no value that satisfy the equation. So no values satisfy the equation. These equations have no solution. Okay, so oftentimes you'll see the solution as this 0 with a big dramatic dash through it. If you write your zeros with dashes through them, please stop for right now because it can be confusing. So this symbol right here means no solution. You could also do curly braces with nothing inside, or you could just flat out write no solution. I most frequently see this and this, okay? So again, a conditional equation has one solution. An identity has infinitely many solutions, like every real number out there works, and then a contradiction has no solution. So let's look at a couple of examples. So first up, let's say we have 3x plus 7 equals 3 times parentheses x plus 1. Okay, let me get another sip of water. Okay, so the first thing we're going to do is on the right, we're going to get rid of parentheses. So I'm just going to rewrite the left for now. And then on the right, 3 times x is 3x, 3 times 1 is 3. Okay, what I want to do next is get all of my variables to the left. That's your next step. So I'm going to move the 3x from the right to the left. So the way I would move a plus 3x is I would move it with subtraction. So I'm going to subtract 3x from both sides. Well, 3x minus 3x is 0. 0 plus 7 is 7. On the right, 3x minus 3x again is 0. 0 plus 3 is 3. So notice the variables cancel, leaving a false statement. 7 does not equal 3, and it never will. This tells me that I'm dealing with a contradiction. That's the classification, and I have no solution. So there is no real number that'll ever satisfy this equation. There's no value for x where this will ever be true. And you can kind of see it at this point. No matter what you plug in for x, you're going to multiply it by 3. Then on one side, you're going to add 7. On the other side, you're going to add 3. You'll never get equality there. Okay? Let's look at another one. So next up, let's say we have 7x plus 9 equals 9 times x plus 1 minus 2x. Okay, so the first thing I want to do is distribute to get rid of parentheses. So I get 7x plus 9 equals, well, 9 times x is 9x. 9 times 1 is 9. And then don't forget your minus 2x. So the left-hand side is simplified. The right-hand side is not. So I do need to combine like terms on the right. So I'm just going to rewrite the left for now. And then on the right, I get 9x minus 2x. Well, 9x minus 2x is 7x, and then I drop down my 9. At this point, you can see that something's going to happen, but let's make it happen. I want to go ahead and get all of my variables to the left. So I'm going to move 7x that's on the right to the left. Well, the way I would move positive 7x is by subtracting it. So I subtract 7x from both sides. On the left, 7x minus 7x is 0. 0 plus 9 is 9. On the right, 7x minus 7x is 0. 0 plus 9 is 9. So notice, variables cancel. They all disappear, leaving a true statement. When this happens, when your variables all cancel out and you're left with a true statement, that tells you you have an identity. And the solution is everything, x, such that x is all real numbers. And again, where I have this blue arrow, you can see that no matter what you plug in for x, on the left, you're going to multiply by 7 and then add 9. On the right, you're going to do the exact same thing. So every single value for the variable, when you plug it in, you're going to get a true statement. So one more example. This one's going to be a little more complicated. It's got some fractions that we need to deal with. So let's say we have x minus 3 over 5 minus 1 equals x minus 5 over 4. Okay. Now remember from several slides ago, let's see, from here, when you're clearing fractions, and I absolutely insist that you completely clear fractions because students hate fractions. Fractions complicate things. So this is the one time you get where you can just remove them. So let's do it. But to clear fractions, you must first multiply each side of the equation by the LCD. So that's exactly what we're going to do. So we're going to look at the 5 and the 4. We want to know what the LCD is. Well, the smallest number that you can divide by 5 and 4 is 20. All right. So I'm going to multiply each term. Remember, instead of multiplying each side, I typically just go ahead and distribute and multiply all at once. So I just go ahead and multiply all terms by the LCD. So I'm going to get 20 times x minus 3 over 5. And then I'm going to get 20 times 1. And then 20 times x minus 5 over 4. Okay. So in the first term, the 5 divides into the 24 times, leaving me with 4 times that numerator. And for now, I'm just going to leave the numerator in parentheses. We'll distribute in the next step. Negative 20 times 1 is negative 20. And then for the last term, 4 goes into 25 times. And I'm left with 5 times x minus 5. Again, I'm going to leave that numerator in parentheses for now. We'll distribute in the next step. So we have taken one quick, easy step. We've multiplied all of the terms by the LCD, and we're left with an equation that has no fractions and is much easier to solve. So let's start. First thing we're going to do is distribute, then we'll combine like terms if necessary. So on the left, I get 4 times x minus 3, so I get 4 times x. and 4 times -3. Don't forget your minus 20 and your equals. On the right, I get 5 times x, which is 5x. And then 5 times -5 is -25. The left-hand side does need to be simplified. If you look here, -12 minus 20, we need to combine that into a single term. So I get 4x minus 32. So -12 minus 20 is 32. And then I get 5x minus 25. You can move either the 4x to the right or the 5x to the left. I generally move to the left. I'm going to do it again in this video just to remind you that you can't have a -1x. Okay, so I'm just going to do that extra step just to remind you. So I'm going to subtract 5x from both sides. -4x minus 5x is -1x minus 32 equals. On the right, 5x minus 5x is 0. 0 minus 25 is -25. All right, I need to isolate my -x. I'm going to do that by adding 32 to both sides. -32 plus 32 is 0. -x minus 0 is just -x. And then -25 plus 32 is 7. But remember, this right here, you are not done, okay? You cannot be done with a -1x. You're done solving when you have a positive 1x or a positive 1y, whatever the variable is. So what we need to do is we need to take our -x equals 7, divide by -1. On the left-hand side, -1 divided by -1 is just +1. +1 times x is x. And then +7 divided by -1 is -7. So here we get a solution of -7. So this would be a conditional equation. All right. So there you have it. We have reminded ourselves how to solve linear equations in one variable. We reminded ourselves how to clear fractions from an equation, which I absolutely insist that you do. We learned a little bit or reminded ourselves a little bit of proportions. We did a couple of word problems. We talked about classifying equations. So we looked at an identity, a contradiction, and again, another example of a conditional equation. So at this point, the bulk of the video is done, but I do want to take a little time for a few extra practice problems, okay? So if you feel happy and you feel like you understand this, you can stop now and go and look at your homework. If your homework doesn't go well, maybe come back and finish up the video, okay? So for now, let's look at some extra practice. So first up on the extra practice, I have 4 times 2x plus 1 in parentheses equals 29 plus 3 times 2x minus 5 in parentheses. So this is just a stereotypical equation. First thing we want to do is get rid of parentheses. We have parentheses on the left and the right. So on the left, I get 4 times 2x, which is 8x, 4 times 1, which is 4. That equals 29 plus 3 times 2x is 6x. 3 times -5 is -15. Now, looking at simplifying, the left-hand side is as good as it's going to get. You know, it's as simplified as it can get at this point if you have one variable term, one constant term. The right-hand side, however, we could simplify it. If you look here, we have a 29 and a -15. Those could be combined. So I'm going to rewrite 8x plus 4. And then 29 minus 15 is 14, and then plus 6x. Okay, so I've combined the 29 and the -15. What I want to do now is get all of the variables on one side of the equation. I like to move my variables to the left, so I'm going to move the plus 6x to the left. I do that by subtracting. And remember, if you do it to the right, you got to do it to the left. So simplifying, 8x minus 6x is 2x. So I have 2x plus 4 equals 14. And then 6x minus 6x is just 0. 14 plus 0 is just 14. I now want to get the 2x alone. My issue is plus 4. The way I would move that is with subtraction. So 4 minus 4 is 0. 2x plus 0 is just 2x. And then 14 minus 4 is 10. We're at the point where we want to isolate the variable and solve. So I need to undo the multiplication of 2x and 10. So the way I would do that is divide by 2 on both sides. 2 divided by 2 is 1. We'll get lazy sometimes and say they cancel, but really 2 divided by 2 is 1. 1 times x is x. 10 divided by 2 is 5. And there you have it. And remember, you can always go back and check. Remember, I think the first like maybe 4 examples we did, we checked our answer. So practice that from time to time, okay? Just keep that skill, we'll say, active, okay? So let's look at another example. For this one, I want to look at x over 2 plus 2x over 3 plus 3 equals x plus 3. So again, a very stereotypical kind of standard linear equation in one variable. We do have fractions, so we want to get rid of those. All right. So looking at my denominators, I have a 2 and a 3. The smallest number that 2 and 3 will divide into is 6. So we're going to multiply every single term by 6. Remember, technically what you're doing is you're just multiplying both sides of the equation by the LCD and then distributing. I just kind of do it all at once. So I have 6 times x over 2 plus 6 times 2x plus 3, or 2x over 3, bless my heart, plus 6 times 3 equals 6 times x plus 6 times 3. Again, you can just multiply both sides by the LCD and then distribute. I just kind of do it all at once. It helps me like understand what I'm doing and keeping track of all of my terms. All right, so for the first term on the left, 2 goes into 6 3 times, leaving me with 3 times x. For the next term, 3 divides into 6 twice, leaving me with 2 times 2x or plus 4x. 6 times 3 is just 18. 6 times x is 6x. 6 times 3 again is 18. Okay? So now the right-hand side is simplified. The left-hand side is not. I can simplify 3x and 4x. So when I simplify those, I just get 7x plus 18 equals 6x plus 18. I like to always start with isolating your variables, like get your variables together first, then worry about your constants. So I like to move to the left. So I'm going to move positive 6x to the left by subtracting it. So on the left, 7x minus 6x is just 1x. So I get 1x plus 18 equals, and then 6x minus 6x is 0. 0 plus 18 is 18. All right, now I need to isolate my x. The issue is this plus 18, so I'm going to subtract. 18 minus 18 is 0, so I get x plus 0 is just x. And then 18 minus 18 is 0. There's nothing to combine it with, so I just bring the 0 down. And it's the funniest thing. Students lose their mind when they see x equals 0. They're like, that can't be. Sure it can. 0 is a real number. So we would say here the solution is 0. All right. So let's look at maybe one more with fractions, one more that's a proportion, and then we'll look at another contradiction and another identity. So let's say that we have x minus 2 over 3 minus 4 equals x plus 1 over 4. Okay, we did an example like this a little while ago, but let's practice another one. Clean that up a little bit. Okay, so we want to look at our fractions. We have a 3 and a 4. We need to know what is the LCD. Well, the smallest number that 3 and 4 divide into is 12. So I'm going to multiply all of my terms by 12. So I get 12 times x minus 2 over 3 minus 12 times 4 equals 12 times x plus 1 over 4. Okay, and then I simplify. For the first term, 3 goes into 12 4 times, so I'm left with 4 times the numerator, x minus 2, and I'm just going to leave it written out in parentheses like this. I'll distribute in the next step. And then 12, negative 12 and 4 is negative 48. And then the 4 in the last term goes into the 12 3 times, and I'm left with 3 times the numerator, x plus 1. So again, you take a couple quick steps, multiply all the terms by the LCD or multiply both sides by the LCD and then distribute, and you get an equation that no longer has fractions. It's much easier to work with. So at this point, we want to distribute. So 4 times x is 4x. 4 times -2 is -8. Don't forget your -48 and your equals. 3 times x is 3x. 3 times 1 is 3. So we want to clean things up a little bit. So on the right-hand side, 3x plus 3 is as easy as it's going to get. The left-hand side, however, we do have this right here. Okay, so we get 4x minus 56. So -8 minus 48 is -56. And that's going to equal 3x plus 3. Next, I want to get all of my variables on one side of the equation. So I like to move them to the left. So I'm going to subtract 3x from both sides. On the left, 4x minus 3x is 1x. Drop down your minus 56 equals. And then on the right, 3x minus 3x is 0. And then 0 plus 3 is 3. So we've got all of our x's in a single term. We need to isolate that, get the constants on the other side. So I need to move the -56 by adding. -56 plus 56 is 0. X minus 0 is just x. And then 3 plus 56 is 59. Now you got your single positive x. You got a solution for it. If you want to, go back and check your work. But we can say with a fair amount of confidence that x equals 59. Okay, let's look at one more proportion, because remember, and it's kind of nice to show it here because you can have a side-by-side comparison. Let's say that we have x over x minus 5 equals 3 over x plus 6. What's different with this example that I just wrote down compared to the one that we just solved is on the left-hand side of the screen, your denominators were just numbers. At this point in your math career, you can find an LCD and multiply by the LCD. This example on the right, though, we don't know how to find an LCD where you have algebraic expressions involved. So at this point in this class, if your denominators contain variables, you can't do the whole LCD thing. But since we have a single ratio equaling another single ratio, we have a proportion, remember those? And we can solve by cross multiplying. Okay, so that's what we're going to have to do here. So I'm going to, you know what? I didn't pick a good one. I think the numerator was not supposed to be a y. I think it was supposed to be a 1 or a 2. So let's change this numerator. It's not supposed to be an x. I think I said y. It's not supposed to be an x. Let's say it's a 2. All right. So again, sorry for that little bit of confusion. Change that to a 2. Let's see what happens. So now we get 2 times x plus 6 equals 3 times x minus 5. Sorry about that. I think I wrote it on my notes wrong. All right. So we cross multiplied. Now we can just solve the equation. So I take 2 times x, which is 2x. And then 2 times 6 is 12. So I get 2x plus 12. And then on the right, I get 3x, which is, or 3 times x, which is 3x. 3 times -5, which is -15. All right. And then I want to solve this equation. And again, I know a lot of you, your gut is going to say move the 2x to the right. That is fine. I'm going to move it to the left so I can remind you one more time that you can't have a negative x as your final answer. So I'm going to subtract 3x from both sides. On the left, I get negative x. 2x minus 3x is negative x. So I get negative x plus 12. 3x minus 3x is 0. 0 minus 15 is -15. All right. Now I want to isolate my x term, so I need to get rid of that plus 12. So I subtract 12. All right. -12 plus 12 just becomes 0. So I get negative x plus 0, which is just negative x. And then -15 minus 12 is -27. But remember, you're not done. Okay, you're not done at this point. You cannot say that your final answer is negative x equals. We always want a single positive variable. So if this happens, remember, you just have to divide by -1. All right. On the left, -1 divided by -1 is +1, which gives us positive x. And then -27 divided by -1 is +27. So there we are. And again, sorry for my little goof. I think I wrote the problem down wrong in my notes. With that x in the numerator, we couldn't solve at this point in our careers. So there you have it. All right, last 2 examples, and then we're going to call it quits. Hold on, it's making me get a new whiteboard going. So I'm going to have to stop something for just a second. Hey, it's me again. Now let me go back and get a new whiteboard. There we go. Sorry about that. It only lets me get so many slides and then it makes me get new ones. Okay, so one more set of problems. We've got 3 times x minus 1 equals 8x plus 6 minus 5x minus 9. So it looks like a stereotypical equation. Let's solve, see what happens. So we're going to start by distributing and combining like terms. So on the left, I get 3 times x minus 1. So 3 times x is 3x. 3 times negative 1 is negative 3. And then on the right-hand side, I don't have parentheses, but I can combine like terms in 2 different places. So I've got variables that can be combined and constants that can be combined. So 8x minus 5x, that gives me just 3x. And then 6 minus 9 gives me negative 3. Okay. Now, I think a lot of you might be able to tell at this point, like, hey, something's happening here, but go ahead and work this problem out all the way. So I want to move the 3x on the right to the left. I do that by subtracting. So on the left, 3x minus 3x is 0. 0 minus 3 is just negative 3. Well, on the right, 3x minus 3x is also 0. 0 minus 3 is 3. So remember, when the variables cancel, you get one of those 2 special cases where it's either a contradiction or the identity. And remember, if you're left with a true statement, this is most definitely a true statement. That tells you you have an identity and you have that weird solution where it's the curly braces and then you do x with a vertical line, which quite literally mathematically translates to x such that, and then just state the solution x is all real numbers. All right, last problem for this video. And again, you could have stopped a while ago. I just wanted to give you extra problems if you're a little rusty on this. So let's say that we have 4 times x plus 2 plus 1 equals 7x minus 3 times x minus 2. All right, again, on the surface, this is just a regular old equation. We're going to start by distributing. We have to distribute on the left and the right. So on the left, I get 4 times x is 4x. 4 times 2 is 8. And then don't forget your plus 1. It's kind of hidden in there, easy to forget. Drop down your 7x and then distribute the negative 3. So negative 3 times x is negative 3x. Negative 3 times negative 2 is positive 6. Okay, so now we want to combine like terms on the left and the right. So on the left, we have 8 and 1 that can be combined. So the left-hand side simplifies to be 4x plus 9. 8 plus 1 is just 9. On the right, we have 7x and 3x that could be combined. So 7x minus 3x is 4x, and then drop down your plus 6. So again, to the diligent mathematician, you can see at this point that something's going to happen, but at this point in your math career, go ahead and finish the solving process. So I want to move the 4x from the right to the left, so I subtract. All right, 4x minus 4x is 0. 0 plus 9 is 9. 4x minus 4x again is 0. 0 plus 6 is 6. And what do we know about 9 and 6? They're never equal. This is a false statement. So when those variables cancel and you are left with a false statement, that tells you that you have a contradiction. And when you have a contradiction, there is no solution. So you can write out no solution in words, or you can do the 0 with that like diagonal dash through it. Either one is fine. Okay. So I know this video was especially long. Let me get you a step back up here. There we have it. So I know this video was especially long. Once you get to the end where I tell you, hey, this is the end of the content, the rest is just extra problems, you know, that's fine if you skip around, whatever. Of course, if you skipped it, you don't see this part. Hopefully these problems are super duper helpful. Make sure you fill out your worksheet. And if you have any questions, please, please, please reach out. All right, good luck.